Hello, mathematicians. Today I have a little baby mathematician with me today that's going to help me do my homework. Can you say hi? Say hi, friends. She's a little shy, not like her mama. All right, let's get started on this Module 5, Lesson 5 homework here. So, whoop, topsy-turvy. All right, so for number 1, remember that your formulas are in your math notebook. So you should have your math notebook next to you with the page of the formulas that I gave you that looks, I'm trying to get mine out. It looks like this. Make sure you have this next to you so you have that to reference, okay? All right, so for number 1, they want us to find the area of the triangle. So over here is our triangle, obviously, and it doesn't have any base or height measurements for it. So we're going to need to figure that out. So I know for a triangle, if I look on my sheet here, I know that a triangle is half the base times height, or base times height divided by 2. So here is the base, and we usually use yellow, and you don't have to highlight if you don't want to. If you want to and it helps, great. Otherwise, you can just kind of use your pencil or whatever. But here is the base of my triangle. Where could I find the information that would be the measurement for that side? Well, over here, it tells me that this side is 9. So what I know about this big rectangle, that if this side is 9, the opposite side is also 9. So this would be 9 over here. And of course, my pencil wouldn't be nice and dark, would it? 9 here. Okay. So actually what I should have done first is, since I need to find the area of the triangle, I should have written my formula for the triangle so I know what I need to find. So when I look at my resource in my math notebook, I notice that the area of a triangle, A, equals base times height divided by 2. So that tells me I need to find the base and I need to find the height. So I found the base here of 9. So then I need to think about the height. These are both diagonal. Do we use diagonals in area? Down to diagonals. Don't do diagonal. No, we don't use those. So that tells me that I need the measurement from the top of the triangle straight down to the base. So how can I find this measurement right here? Well, I noticed that the top of the rectangle, has a measurement of 24. So how can I use the fact that the top is 24 and this part of the this line segment here measures 18? What can I do with that fact? If this is 24, this part is 18, if I know that I need to find this piece right here? Well, hopefully you said, if this is 24, it's 24 is the same as 18 plus some number. So I have this equation here. I could solve it algebraically, or I could think, if this is 18, how many more do I need to get all the way to 24? So lots of ways to solve that. For me, I would do it algebraically. I would subtract 18 here, subtract 18 here, because that's how I undo and added 18. And I would use my calculator, because we can use calculators on this unit. 24 minus 18 is 6. So that tells me that x is equal to 6. So my height here is 6. So now, if I know that this is the formula to find the area of a triangle, see if you can plug in the formula and solve it with your calculator to find the area of that triangle. When you are finished with that, check back in to see if you are correct. All right. So I would have done A equals 9 times 6 divided by 2, or you could have written with a division sign. So I know that 9 times 6 is 54. So I need to do 54 divided by 2, which I'm going to use my calculator for just because I'm lazy. And I get 27. So that tells me that the area of this triangle here is 27, and since we don't have any measurements, it's 27 units squared. So hopefully you found the area to be 27 units squared. So now it says find the area of the rest of the shape. So that tells me that I don't want it with the triangle in it. I just want the rest of the shape there. Okay, so I need to problem solve. How can I find the area of these two pieces here? Well, there's two different ways I could do it that I see. I could find the area of this trapezoid, and I could find the area of this trapezoid, and I could add them together. That's one option. Or I could find the area of the entire rectangle here, and then just subtract out the area of the triangle that I already know is here. I think that way would be a little easier. So now, what is the area formula for the area of a triangle? Look at your resource and write here what the area of a rectangle is. Then, using that formula, use substitution and solve that here. After you have the area of the entire rectangle, so this would be the area of the entire rectangle minus the area of the triangle, which we have up here, which is 27, that should give you your answer to the rest of the area in that flag. Let's look at number 2. Number 2 says if DC equals 1.9 and DC is the line segment name for D to C. So it's this part right here is 1.9. If that's 1.9 and FE is 5.6, so that would be this part right here, 5.6. AF is 4.8, so A to F, 4.8. And BC is 10.9. Here's 10 BC. Find the length of the other two sides, then find the area of the irregular polygon. So we need to know what is the length of A to B. So we have A to B going across here. So here's A to B. How could I find the length from here to here? Well, I noticed that here is a part of this line. So if I know from here to here is 5.6, that tells me that up here, that would be 5.6 as well. Now, how can I find the length of this section right here? Well, if I cut this into a rectangle, that tells me these two opposite sides are congruent, and it also tells me that these two sides are congruent. So that would be 1.9. So the length of this side would be both of those together. So I would use my calculator, or I could line up the decimals and add them together. And I get that that side is 7.5. So that one's 7.5 centimeters. And then somebody found my candy stash. See if she can get it open. Sorry for the distraction. The next one we need to find is this E to D here, or D to E. So again, what do I know? Well, I know that this side is 10.9. So I know that the whole thing has to be 10.9, but I don't need the whole thing. I only need this part right here. So can I find either this part or this part? I can find this part because it is opposite of this side. So that tells me if this is 4.8, then this is 4.8. So if this has to be 10.9, 4.8, what would that leave that? So if I take the 4.8 off of here, so 10.9 minus the 4.8, again, I'm going to use my calculator because it's an option, so why not? I get 6.1 left over. So that tells me that this section has to be 6.1 because these two together is the same as this one. So now that I have DE and I have AB, I can now find the area of this irregular polygon. So I would find the area of this rectangle and the area of this rectangle. I would use my formula sheet in my math notebook to know what the area of a rectangle is if you don't have it memorized already. I would use in my notes where we marked the length and the width of the rectangles. And then I would find the area of this rectangle and the area of this rectangle, and I would add them together to get the entire rectangle. So see if you can do that part. All right. For number 3, it says determine the area of the trapezoid below. The trapezoid is not drawn to scale. That means you can't just assume that this one looks smaller than that one, so we're going to guess that it's about 5 or something like that. You have to just go with the pieces that are here. And it says you may cut it into triangles or use the formula from our math notebooks. I personally think the formula from the math book is the easiest way to do it. So, well, she can get it open. Did you get some candy? Yeah. Say yeah. Yeah. So I'm going to use the formula that is given to us in our math notebooks. So I go to the trapezoid and it says A is equal to 1/2 the height times base 1 plus base 2. Okay? So I see in my notebook that base 1, if I'm looking at the example, is one of these. Base 2 is yellow, so it is this. And then I see that the height would be the distance between both of them in a perpendicular line. So the height is that one there. So now all I have to do is use substitution and remember the order of operations to solve this problem. So I would plug in the length of the B1 and the B2. I would add those together because PEMDAS, parentheses. We haven't done our 20 things to remember in a long time. PEMDAS, parentheses, exponents, multiply, divide, add, subtract. Why did I write it like that? Multiply, divide, add, subtract. So I know I need to solve this first, so I would add those two lengths together. Then I would start multiplying, and for me, I would use the calculator and do 0.5 instead of 1/2 times whatever my height is here, times whatever is the sum of the two bases. And that will give you your area. Don't forget your label here using your calculator. All right, that's all I'm going to do for this video. Video 2 will cover the back if you still need it. If you think you're good on your own, go ahead on your own.